Good morning to you all. Today we're gonna dedicate the day to artificial intelligence, or AI as it is called. We have a program full of different cases. We have lectures, we have workshops. AI is the technology that most consulting companies, leaders in the world, says that this is the most important single factor for future value creation. My name is Odd Gurvin. I'm project manager at Norwegian Cognitive Center. We will present the center a bit later in this meeting. And first of all, now we're going to meet some companies that has used AI or using AI in their daily work. First of all, we start with Mjoll. It's a Norwegian company within the fund group, and to present their solutions, we have Ingrid. Welcome. The scene is yours.
Good morning. It's my pleasure to be here today on behalf of Mjoll, one of our companies in Fund Group. I'm here to talk a little bit about our product that utilizes AI extensively, amongst other features, and also to show you a little bit of how journalists and editors use AI in their everyday job. So, as introduced, my name is Ingrid Agasøster. I noticed you didn't say my last name. It can be difficult for some. And I am the COO in Fund Group. We are a small tech group here, born in Media City Bergen. We currently have 3 companies in our group, and a 4th is on its way out in the market. I'll come back and talk about that. We have Mediability that probably some of you already know. They are a professional system integrator and equipment reseller, providing everything from lights and pedestals and cameras and studio infrastructure to companies in the Nordics. We have Mjoll, the company that I will present today, a software company developing cloud-based tools for media production primarily. And then our sister company, 7 Mountains, they are also a software company that have developed Dina, a story-centric newsroom platform that also runs in the cloud. So I was supposed to, you were supposed to meet Steinar Søreide here today, our brilliant CTO in Mjoll. They are fortunately very, very busy with the customer projects and development, so I'm stepping in for him. Steinar started working on Mimir back in 2018. They were a group of media tech nerds following the trends in the market, seeing that there is a lot happening in the AI space, a lot of available AI services opening up from vendors such as IBM, Microsoft, AWS, Google Clouds, etc. And they saw a need in the market to tie this together to a workflow tool for end users. It's built on AWS architecture, 100% serverless core, and it launched already the year after, when we also registered the company in the market. So we went live with the first customer in 2019, and today we have about 30 customers worldwide. These are some of the customers that we have. You probably recognize some of the logos. A lot of them are in the media, broadcast and production markets, but we also have customers such as World Health Organization, recently signed Emerson College in the US, and large media house Axel Springer in Germany. And for example, Deep Ocean. So it's really everyone working with video content can use Mimir. I'll get back to that a little bit. So a journalist today needs to work fast. they need to handle content on multiple platforms, and finding the material that they need for their stories is crucial. They need to be able to find the videos and images that they need fast. And to do that, it is crucial that we, for example, log video metadata. But many does not do that at all. Even production companies tell us that they film throughout the week for a long-form production, for example, ingest over the weekend and hope for the best, and really don't spend any time on logging who's in the video clip, what are they talking about, what's the topic, objects, persons, etc. This is called metadata logging. And of course, this gives very poor search possibilities within their own media archives. And it's hard to find what they need, and many don't reuse any assets in their media archives at all. And this is where AI comes in and can help. We have built Mimir. It's a powerful workflow tool in addition to tying a range of AI services into one unified workflow tool. It automates a number of time-consuming tasks for a journalist or editor, such as speech-to-text transcription, translations, detecting objects in videos, event tagging, and more. I'll get back to that a little bit. And then it also integrates into a complete workflow tool. It integrates with Adobe Premiere Pro and the Avid platform for editors to work on their projects and move media files efficiently between the systems, and also do rough editing, working on high-res material, proxy material, etc. It has a lot of features in the cloud production workflow. I'm not going to go into all of that today. And we've also spent a lot of time on developing a fantastic user interface, making it easy for producers and journalists and editors to use the tool on an everyday basis. Mimir is positioned both as a cloud production asset management workflow tool. That's quite complicated. It means a lot of features within live workflow, scheduled ingest from the cloud, streaming, and rights information workflows, and more. It has a ton of features built on top of what started off as a tool for basically moving your files to the cloud and then utilizing AI to work more efficiently. Today, it's a complete production asset management tool. But today we focus on the AI, and Mimir, we like to say that we bring AI in the hands of the journalists and the editors. So a practical use of AI in their everyday work. It ties together AI technology that is already there. It's important to say that we are not developing our own AI engines. We rely on the giants out there that has made their development APIs and SDKs available to integrate. So we integrate with AI services from AWS, Google Cloud, IBM Watson is integrated, Speechmatics, Scriptix, and many others. Our team do spend a lot of time monitoring, having a very close relationship with these companies, making sure that when there is a new technology available or a better service available for speech-to-text transcription, for example, or face recognition or whatnot, this is available in Mimir. A lot of these services are available through open APIs, so basically any news company or media company can utilize it. But of course, this requires development resources, and it's not something that you can just translate into a workflow tool for the journalists. This is what we've done with Mimir. So we can say that Mimir uses very complex technologies with these AI engines, and makes it radically simple to use for the end users, being the journalists and the producers primarily. We think that, for example, search, that should be as easy as Google. And the user interface should be as easy as any social media platform. That means that it's super easy to access and find the content that you need because you have logged your metadata. And many of our customers say that they, after starting using Mimir, they also now discover content that they knew they had, but they could never find. And of course, that is value for money, that you can reuse your content, whether it's a segment from for a news clip or you're working on a long form project, documentary, or whatnot. Yeah, so I'm going to show you a little bit about how customers use Mimir. I'm not going to do a live demo. That was too risky, I felt. But so I took some screenshots yesterday. So this is the Mimir user interface. It runs in my browser, so the user can use their favorite browser to access the system from anywhere. And in this example here now, I'm looking for a video clip in my database that has Trump in the image. You can see my little search terms there. I've searched for person Trump, person Obama, and I want to have a car in the image. So it gives me my return hit here, and you can see this is the item found. President Obama, President Trump, and a car. One simple example, but it illustrates how easy it is to find content in your database with combining different search terms. We can search for persons, we can search for objects or labels, so car, helicopter, shirt, conference, bar, party, whatnot, mountain, everything that's detected using these AI engines, you can use as a search term. And I also have an example here where you can also search in the spoken words in the transcript. So if you are looking for this clip where Donald Trump talks about fake news, I just entered a very simple search term here. I get a ton of results on that. We have quite a lot of material with Trump talking about fake news. And then the journalist or the editor can go into the video clip. Let me just see, yep. And then see exactly in the timeline, in the transcript, where he said fake in this example. So now you can start imagining how powerful this is for a journalist who may be working on a story where a certain individual needs to be in front of the Eiffel Tower or something, talk about climate change while there is a helicopter flying in the background or whatever. It's extremely powerful. And the journalist will then, down here, it doesn't show very well, but you will get the hits in the timeline for the video for every time Trump appears in the clip and says this specific word that you searched for in the transcript. And because we integrate with, for example, Google Cloud, we can, let me just see here, yep. And Amazon also has this service, IBM, I believe also, a very, very powerful persons and celebrity detection database. In this example, this is Dr. Fiona Hill that is detected in the video here automatically and found in the celebrity database with a 98% certainty that it's her. And you can also see that the AI service here has detected a number of other persons and then predicting who this probably is based on the celebrity database in this example. And a media company can use the celebrity database that holds millions of people with images and titles. And they can build their own person's database with, their local politicians, their local TV hosts or whatnot. And then detect the individuals in the clips, making it, again, super easy to find what they need for their stories. We can take any language in. We can transcribe audio to any language of your choice. This is really up to the user to pre-select how they want it transcribed. In this example, the clip is in Arabic, it's transcribed in Arabic. At the same time, the user has enabled translations in 3 different languages using Google as platform for translating. And that means that when you are searching then for the content with this, for this clip, whatever he's talking about, I don't know, you can search in any of those languages, the original language that it was transcribed from, and also the language that the transcript is translated to. So in this example here, let me show you, we have the English translation of the Arabic clip, and the journalist can search then using English search terms. So this is used a lot by our editorial or journalistic users. Yeah, I don't think I have much more to say, just a little bit about the customer feedback. Some customers started using Mimir simply to get their content from on-premise servers to the cloud. And then they discovered that, oh, this product has a lot of cool AI stuff that we can use. And people really enjoy being in the forefront of using AI technology. So it creates a lot of engagement in the organizations. We have innovative customers that are using this platform. And we can tell that, you know, they feel great about being in the forefront of actually using AI in their everyday work. Some customers say that they've actually saved up to 20% of their time after starting to use Mimir. And this is time used on the boring tasks, such as transcribing audio to text. This can, of course, be done manually, or you pay for an additional service to do that for you. And then, of course, the logging is the time saved on not having to log, categorize, and translate videos saves a lot of time. And because it's built with that idea of it being as simple as Google for search and as simple to use as Facebook or Twitter or any other of these platforms, the customer experience feedback is really good. I do have a little video to sum it up. If we have time, it's like 3 minutes, in case you didn't catch what I said. We have a little marketing video. I will be hanging
here's
out.
The problem.
Yeah. Oops,
You've
sorry.
invested a lot of time and money to create great and meaningful media content. But once it's archived, it's difficult to find and reuse that content. You had no time for tagging or logging your videos and images, making it impossible to find back to what you need. Are you looking for a smarter and more efficient way to work with media content? Mimir is a browser-based media management solution. It's a tool for journalists and video editors, or anyone working with video, for automating the boring and time-consuming tasks, such as video and image metadata logging, speech-to-text transcription, multi-language translation, event tagging, and much more. With Mimir, you can create better stories faster. With Mimir, you can access and find your content in a fast and secure way. And you can discover content from your existing media archive. Mimir harnesses the power of market-leading cognitive services from Amazon, Google, IBM, Microsoft, and others to automatically make your archives searchable and therefore more valuable. With Mimir, you bring AI and cloud technology to your end users, and you have full control over what AI services you want to use. Creative professionals spend a significant amount of time searching for media assets. Mimir customers say, we save more than 20% of our time by using Mimir for automating our logging processes. We can now search our existing archive instead of creating new media content. And artificial intelligence is now part of our daily workflow. You can access Mimir directly from Adobe Premiere Pro, hosted within the editing application. This makes all the regular Mimir functionality available for the video editor, and you can import clips into your project, create subclips from text selections, and much more. With our Proxy Workflow, you can choose to work with proxy or with high-res material. With Proxy Workflow, the files are only 1 to 2% of the original content size. This allows you to use less powerful computers, and you don't need to worry about your network or internet connection. This especially applies to when you combine it with a central conform workflow. And last but not least, with a Proxy Workflow, you avoid expensive download costs. Mimir is easy to use, and you can start with your first users today, without any installation. Contact us for learning more about Mimir.
Thank you so much, Ingrid. This is what we call value creation. And it would not be possible without AI. So it's quite exciting tools they made. Next up is Ketil Malde. He is working at University of Bergen and will give us all an introduction to how they will use AI in marine research management.
Yes, thank you. Yeah, how do I flip the pages? Here we go. Thank you. Always good to be prepared. Thank you so much for having me. So I'm from the University of Bergen, where I teach machine learning. But my main job is at the Institute of Marine Research, where we, well, let's see. Our task, our purpose is to understand the oceans and the ecosystems so that we can give management advice and environmental advice to the authorities. So we try to address important questions in ecosystems, understanding how species interact, how our important commercial stocks develop, how they grow and shrink, so we can give fisheries advice, and also species behavior on a small level. So we're trying to understand how the ocean works. And to understand, we must observe. So we collect data in many ways, and as technology improves, we have gotten better and better equipment for capturing images. So these are some examples of image capturing technology that we can deploy in the field. We, of course, do the same thing in the lab. So these are some lab images of various kinds. It's not all images, of course. We also do many kinds of remote sensing, and we can use satellite data. We can use echo sounder data. And sensors of all kinds have developed a lot lately, but we are also simultaneously getting these autonomous platforms, so we no longer depend on sending an expensive research vessel out to capture this data. We can just send a robot. And not a rowboat, but, you know. So, what was it the last speaker said? Something about you don't have time you no longer have time to tag or log metadata for all your data. And this is the old model. I drew some boxes for you. So in the old days, a single scientist would go out and carefully make some measurements or take some samples, bring them back to the lab, analyze things, and build understanding. Today, our data is growing tremendously. So because everything is automated, resolutions are improved, frame rates are higher, we get lots and lots of data very cheaply, and the scientists really like that. But this gives us a bottleneck. So going from data and analyzing it. So logging and tagging is one thing, but actually looking at all the data to extract the information you need is an insurmountable task. So that's where we try to apply machine learning methods to help us to reduce this bottleneck. So that's what we do, and we are scientists. So these are some of our scientific publications where we have built systems to help us analyze our data. So that's the background. That's where we are. So I thought I'd give you a small case study, one example project that we work on. And that's acoustic troll surveys. And they kind of look like this. So we take a ship. We use an echo sounder. That's the sort of triangular beam down from the ship to measure the amount of biomass in the ocean. So it could be fish, could be plankton, and we get an echo, so we can sort of try to say something about the quantity. But it's difficult to know exactly what you are looking at. So simultaneously, we typically also trawl the ocean, capture some fish, and then we can bring them up on deck and count them and measure lengths and identify species. So this process is not so good for the fish because it gets captured, it gets killed. So we'd like to do this in a less intrusive and less harmful way. And if we can do that, well, what can we do? We can scale it up, right? We can send a robot ship, maybe. So we would like to use just a camera to record the fish in the what we call the water column in the various depths in the oceans. We have an industry partner who has developed this trawl camera. This is the blue box on the left here. This is in the middle of the trawl, so this is where the fish gets funneled through before it gets captured in a big bag to be pulled on deck. And we get the kind of pictures you can see on the right. So here we see some mackerel and some herring. So this is what we would like to get. So this, on the bottom here, you see the echogram. You see the blue clouds that represent the presence of something. And then the trawl has followed this, maybe I can point, follow this black path here. And these are the fish observations. This is all manual, but we would like to do this automatically so that we can say that, okay, here we have the red kind of fish, which is probably blue whiting. And here we have the greenish thing, which is haddock. And then we can measure the quantities with from the echo sounder echo strength. So the idea is, can we use these images on the left to replace what we are doing on the right, where we have captured a large amount of fish? So we try to do automatic species. I mean, we capture tens or hundreds of thousands of images, and the biologists really like that, but they're not going to look at all of these. So we want to automate this. And this is something that machine learning can do for us. So we use a system called RetinaNet, and this is just a standard architecture that can identify things in images, and we train it. Since we don't have a lot of label data, so it's too time-consuming to label a lot of data, we tried a trick. We simulated some data by taking some empty pictures, just the background, the inside of the box, the yellow square on the left, and then we cut out some real fish from some images. Oh, we cut out the images of the real fish, and then pasted them randomly in the images to create something that looked reasonably realistic. And then we get this kind of output. I don't know if you can tell, but here the system has drawn a nice green box and said this is a mackerel, which is exactly what it is. So now the system seems to do what it does. And since we're being scientific about it, we try to quantify the results. And we get this performance measure, MAP, of 0.85. And we think this is really good. But I mean, it's just a number. But we tried to also try different numbers of simulated images and see how many do we actually need. And we see that, well, the more the merrier. So the darkest color is up here where we have the most data. That's really unsurprising. So being scientists, we want to publish this as a scientific publication. And we could do this. We could say, write a paper that says, well, we had some data. We applied a cool machine learning method. And yeah, we got the result. Great. But it's not really that informative. It's something you can do. You will always get a result, and these days you can usually always publish it. So we want to go a bit further. We're not interested in actually identifying fish in the images, right? we are interested in, can we replace our trawling with this system? So we went back and tried to reconstruct the catch numbers from the numbers we get out of the image. And that's a much more complicated question, because there are many problems. One is the performance of the classifier, but another one is that, well, the fish, what's it going to do when it gets into this box with a flashing light? It's trying to swim out of it, and usually it can't, but it will stay in the box for quite a while. So we get a lot of pictures of some fish, and if it swims the other way, sometimes happens, then we maybe just get one picture or maybe none. So we try to fit the regression to this, and we can do that, and we get reasonable results. But there are some challenges. So, and then I have to admit, then we published this result. So that's the paper. You can read it if you want. But we haven't really solved anything by this, have we? I mean, what we wanted to do was to replace our trawling. And it's not sufficient to build a system that works. It also has to be we actually have to fit it into the existing structure to replace the old system. So that means, so we can do this as a project. I can take my little team and we can get some data, program a bit and solve this, but we need to turn it into a process. So that involves a lot more steps, right? You need to build a system for data processing. We could do this manually, but we need to automate it. Storage, organization, we need to make sure we have the necessary processing hardware and software. We may have to go back and update the model, so there needs to be some maintenance system. People must be trained, and the organization must be structured. So this is no longer the work of a person or a small team. This is the work of an organization, and I'm just, working the factory floor. I can't really do this. So some of the challenges here is, typically you end this paper saying more research is needed, because then you can cite your paper when you apply for more money and say that, well, scientists say that this is really important. But if you look at, this is the performance curve from 2011 to 2021, so 10 years of machine learning development and the most important image classification benchmark. And what you see is that, things happened really quickly. 10 years ago, performance increased tremendously. And then it kind of flattened out, and well, we're getting close to 100% here, right? So there are limits to how much better it can be. And also these later advances are small, but also they typically use very large and complex and expensive to run systems. So basically, technologically, this was solved around here, so like 5, 6, 7 years ago. So the technology is there. We can use a fairly old system in machine learning terms. And also the technology is available for download. So these big technology giants, along with many universities, publish their stuff. So you can just download the code and adapt it a little bit and run it. So we use machine learning frameworks like PyTorch and TensorFlow. We use Docker to containerize, so we can take the systems we develop on our computers and run them on the computer on the ship easily. We have visualization tools, we have powerful computational tools. So we have all the great tools, and we have the architectures. But the first challenge is, again, this, recording, metadata, labeling, and logging, just processing the data. And while we can automate it, the data needs to have structure for us to do that. So it needs to be organized well. So especially we need training data, and we need somebody to label a lot of data so we can train our system on it, and they have to do it in a way that's machine readable, so I don't have to go and do a lot of manual work to get the data in shape. And this doesn't really sound like a very difficult problem, but in practice it is. So people do all these things like okay, so we need to label the data. Okay, then I took Photoshop and drew boxes in the images and of course save them to replace the original images. They're completely useless because then my system will learn to detect drawn boxes, right, and not the fish behind it. People will make up new labels. So if you have a set of labels, but you know that in this particular cruise there is only cod and herring, so if I see a mackerel, I'll just label it herring because I'm interested in cod. So, but when I get this data, then I have a lot of mislabeled data. And sometimes people only summarize information. This is really common. They will, if they look at 1,000 images, they will just write on the back of a napkin the total number. So I can't really map it back to the raw data. And people don't, I think people don't understand how computers work. Sorry, I'm a technologist, but you have to understand what's machine readable. You cannot really change a label and expect the computer to understand what you mean. Okay, that's my little rant. And when we get to the deployment, so that's the other. So getting the data in shape so we can actually build a system is one major challenge. The other major challenge is deploying it in the organization. And again, you meet a lot of resistance to this, right? I like to say this, that people would rather have a problem they can't avoid than a solution they can't understand. So there is a lot of conservatism. We have always done it this way. So nice thing about a computer is you can program it and it will do exactly what you specify. But if you take a person and tell the person exactly how you want things done, and then the person will go back and do it the way he or she used to do it. So it's very hard to change. People are afraid and uncertain and doubtful. They're afraid to lose their jobs to a robot. Maybe there's prestige involved. If you were the world-leading expert, highly paid and much respected for being the expert at identifying mackerel and herring, and if I build a little program, I mean, I have hardly even seen a fish. You're not going to like being bested by a computer. And of course, there's a lot of organizational inertia. So this is, in my experience, this is really hard to pull off, and it needs a lot of support from across the entire organization. So just to conclude, so I'm a technologist. I'm really fascinated by technology. I think that machine learning, artificial intelligence is really amazing, and it's going to go way beyond just processing data, which we are talking about here. We're going to actually build the ecosystem models. Are incredibly complex because everything affects everything, right? So maybe the cod eats the capelin, but if the capelin goes away, that doesn't mean that the cod stops eating. It's just going to eat something else, but you don't know what until you've actually seen it. Technology, I think we have the great tools, but data is a continuous challenge. We try to solve some of it with our simulation, and we need to find better ways of doing similar things. Deployment is a really hard nut to crack, and that's why the transformative effect of artificial intelligence is taking so long. So we need to address not primarily the technological challenges, but integrational and social and organizational challenges. So with that, I just want to mention this. These are the team that are behind the acoustic trawl work. So thanks to my wonderful colleagues, and thank you for listening.
Thank you very much, Ketil. Some of the challenges that you mentioned, we gonna maybe listen into when the next presenter is coming. This is Dag Pettersen at Sharecut. In a webinar June last year, I got a call from Dag and said, we have a lot of data. We have some issues that we think that Norwegian Cognitive Center and others could help us with. Could we have a meeting? And they have now worked for 1 year with the project, nearly. And this is the first time I'm going to listen into what they've learned. Welcome, Dag.
Thank you, Odd. Thank you. As Odd says, my name is Dag Pettersen. I'm CEO of ShareCat Solutions. And I guess as the slide shows you here, data is kind of our focus in life. The phrase data science, we're a 25-year-old company, so we've been around for a while. So what I'm going to present to you guys today is a journey that we have embarked on. We have an existing technology platform, which is actually quite excellent, but it still needs to be improved. And this was, as Odd says, when we started looking at the new technologies, but also then kind of starting to dive into the phrase data science, which actually is what we've been doing for 25 years, but we didn't actually know that it was called data science. But if you look at the data science life cycle, that's basically what we've been working on for 25 years. When I speak about data, I just like to set the context a little bit. So data in our world is basically what we call plant data, or data that actually describes the actual production facility, an oil production facility, chemical plant, power plant, a wind turbine. And each of these plants, as we call them, consist of hundreds of thousands of equipment components, where each and one of them, they need to work together, but they also need to be documented with data and documents. So our focus in life has actually been to look at how can we actually provide a technology that can help these guys get this big jigsaw together, because it's a really complex world. And we use a combination of we call it multidisciplinary people. We have engineers, we have data document controllers, we have IT people, all different kinds of people who actually make the mix of our team, and which has developed our platform. As I said, we've been around for a few years, and as you probably can see here, we been accepted actually as a solid provider of solutions. And the companies you see, the logos you see here, are among the largest corporations in the world. We're a small Bergen-based company and are well reputed across the world for what we do and how we actually help the industries dealing with all these big information management challenges, as we call it. And as you see here on the right-hand side, there's just a list of a few multi-billion-dollar projects worldwide that's actually using our platform. And obviously what we need to do is make sure that our platform is stable, reliable, available, and not last but not least also secure, because there's information in here that's going to be, some of it's almost generally available, but others are top secret. There's new inventions being dealt with here. So that's what we need to deal with. We also work with what we call industry clusters, which are kind of big clusters of actually companies. So Norsk Olje and Gass have something they call a digital samhandling, and they have established a common solution for the Norwegian continental shelf, and they're using our technology platform. IOGP is all the 80 largest oil companies in the world who actually under association, and they are now engaging with us to actually establish a common platform across the world to deal with this. So what is ShareCat and what is it about? The world of information management in what we call asset-intensive industries, e.g. industries that have complex production facilities, is that you have the big complex assets comes actually and being built from multiple 500 to 1,000 companies can be engaged in building a production facility. And all these guys are then delivering obviously the physical component to build it, but also data and documentation, which are required by the owner-operators to actually build and operate the production facilities. And what we see is that the information out there is in multiple formats, multiple languages, and they are then delivered up through a complex supply chain. I sometimes use the example where I say, okay, so Equinor goes to Aker Solution, build me a production facility. Aker Solution turn around to Laviksveis, say, I need a living quarter. Aker's Laviksveis turns around to Stahl Heiser and asks for, I need an elevator. Stahl Heiser turns around to Siemens, I need a motor for the elevator. Siemens turns around to Emerson and asks for, I need some transmitters and instruments for my motor. And that's the supply chain, and then you have to physically deliver and also deliver all the data and documentation associated with those components. And then on the other hand, all this information then goes into multiple different systems on the owner-operators. So basically our role in life is basically to be an intermediator in between here, collect all this information, validate, structure it, format it, so it meets actually the requirements for the building phase, but also and the operation and maintenance phase. One of the things we learned, though, during our journey is that quite a significant part of this information is actually what they call standard information, where they actually don't engineer equipment, they just go and buy it. And if we look under the hood to ExxonMobil, Shell, BASF, whoever they are, we're actually seeing the same components being used over and over and over again. So the idea behind ShareCat is basically, what if you had all this information available for reuse? And that's kind of a core element in what we do. But then over 25 years here, I'm not going to go into all the details related to this illustration here, but over the years, we have actually collected millions and millions and millions of data, documents and data attributes and so forth that actually sits in our platform today. Obviously, some of it is very sensitive and cannot be reused, but it's sitting there. So obviously, we can use meta elements of those data. But then we started looking at, hang on, even with our existing platform today, there's still a challenge here for these guys to get the information from their format into a format which these guys on the other side need. So that was kind of when we started looking at, okay, we started to learn about smarter technologies that actually can help us doing that. And that was when a concept, when I spoke to Odd here, the idea about the information factory was born. Say, hang on, if we can start looking at smart technologies that actually can help us utilize the whole process of taking this data in, structuring it and so forth, what would the benefits be for that? And I think our conclusion, or at least our hypothesis, was that it was enormous. So the information factory for us is basically looking at a computer-driven capture and conversion, enrichment, validation of data, taking it from multiple formats and then understanding what it is, and then represent it, as we say, from any source to industry standards. Industry standards means that all the what the big owner-operators in multiple industries try to do is actually use a common way of describing components. They don't today. There are multiple ways of describing a given component. Sounds strange, but that's the way it is. So what we're looking at is say, okay, if we can develop some smart technology here and predict what is this, and then put it into that format, and then represent it in whatever format you want, and do this in an automated way. So this was kind of the idea we had, and obviously, as was mentioned earlier here, we don't either want to be kind of the AI developers. We actually want to use our domain knowledge and skills and utilize what we say best of breed technology, so we can focus on what we are good at, but utilizing then these technologies. I guess the other thing for us is that since we are a going business with an existing cloud platform, for us it's going to be an evolution and not necessarily a revolution. we have clients, big clients, utilizing what we have today, so we need to work out a smart way to utilize this without interrupting the services we already are delivering on our platform. So that's why we say evolution and not revolution. So we then embarked on a journey. The conversation with the NCC and so forth kind of started it. But before that, we actually went on to what we call an applicability assessment. We had this idea that there might be technologies out there that could help us. We then engaged with some external experts to have a look at our business. And they learned us a little bit about the different technologies, but they also dived into our business to look at other specific areas here where this technology actually can help you. And what you see on the top here is basically we looked at what we call use cases. So we identified 25 use cases that we could actually apply AI on. And then we defined them, described them, what kind of training data do you need, what input type data, what's the complexity in actually solving this problem, and what's the business value. So we classified each of these use cases and then selected a few of them to get, okay, makes sense. The conclusion of that assessment was, yep, it's really a huge benefit for you guys in Scheka to start deploy this and for your clients. So what we decided then to do, and that was kind of where the conversation started with the Norwegian Cognitive Center and IBM, we actually took then Watson Discovery and kind of set that up for what we call a minimum viable product. Let's test it. And what we did here, we used then some product catalogs. So the OEMs, or the manufacturers of equipment, they very often have big catalogs where they describe their technical products. And they use that as a basis actually to generate data that they have to deliver to their clients. So as you see here, we took then 8 product catalogs with a little bit above 2,000 pages. We trained the engine, and then less than an hour per catalog, and we actually were able to extract 13,000 products out of those catalogs. So for us, that will give, okay, that's a big value for the OEM who owns this, because suddenly his data is available in a data format that the industry actually can use. And for the user, the engineering contractors, the owner-operators, suddenly data are available much quicker, much easier. So based on the outcome of that, we decided to move on and establish what we call the version 1 of the information factory. And again, very detailed illustration, and I'm not going to go into the details, but there are in principle 3 columns there. One is what we call the data ingestion. It's actually get the data in, try to understand what it is, what do they try to achieve. Then we have then the data processing, where we have established something we call buckets, depending on the scope and the outcome of the data ingestion. We actually then apply different processes, different tools, and so forth to actually start processing the data. So that's kind of the second step. The third step is then present the data. So as you saw in the earlier drawing, what I tried to do there was basically saying that information factory sits kind of behind the platform, and it's a back-end engine that produces data that the platform then can benefit from. So that's the kind of the logic that we've established for our information factory stage 1. There is much more to come. We have in this stage 1 taken 1 or 2 of the use cases, so we have more than 20 to go. And what we decided to start with, obviously, was the ones with low complexity and obviously the highest possible business value. The outcome, so our information factory version 1 goes live next week, and will give us significant benefits because we also provide supporting services to our technology platform. So this actually process will help our employees. The platform information factory will come up with suggestions, pull in data for them to actually establish these data records that we are working on establishing. And then we have working on what we call a big master plan, where we actually then are going to embark on the next use case, the next use case. And in that process, we have then decided to go into a partnership with IBM and utilize their Watson as one of the core components in our information factory. And we are also literally together with IBM looking at some major international opportunities where we are looking at deploying this type of technology. So we are still in the, what do I say, infant stages of deploying this. So compared to some of the other presentations, we're not there yet with a ready product. And the way we select to do this, since we are in this big complex world, we say that we provide this internally first, test it out, see that it works, and then we will gradually embed it as a self-service in the platform. But we have to take this step by step. And I think the former presenter here talked about behavior and deployment. And obviously here with thousands of companies involved, huge corporations where we very often meet people from different departments where we introduce ourselves and they introduce themselves to each other because they haven't met before. So obviously that illustrates the challenge in deploying this, and that's also getting back to what I said, evolution, not a revolution. Yes, so I think that was basically what I had. Obviously I could talk forever about this, but with limited time available.
Thank you very much,
Yep.
Dag. Before you leave, I have one question.
Yeah.
And that's how are the employees adopting this project?
I would say our employees, I can group them in two categories. Obviously, you have the guys working with this. So we have recruited data scientists and some specialists, product specialists. They're really engaged with this. But one of the things we're working with, obviously, the services people who are literally working with data today feel a little bit threatened. So actually what we're then looking at is explaining to them how this actually will help them and how we actually can scale and become much bigger and reach a global market by having them dealing with much more tasks more efficiently than they do today. So there's a little bit of, or say not resistance, but skepticism in the organization about what about, and it's a classic job protection thinking here. What's going to happen with my job when this comes in? Well, your job is going to move a level higher. You're going to be the expert, and you will have the computers doing the groundwork for you.
I'm going to ask you one more question, because Norwegian Cognitive Center has been, as a project, been here for a year, and we meet a lot of different kinds of customers. And what we see is that the top management often doesn't know the consequences of AI, using AI. In your case, the top management come to us and took the organization with you. But in a lot of other cases, it's the geeks, the nerds, who is coming with the project and try to sell it up. How has you been working with the organization regarding use of AI?
So this was actually, as you say, it was an idea that came up a couple of years ago where we looked at this, and that this was actually born in the management team of the company. So this was kind of top management. So obviously, as I say, as a CEO, I sometimes say that it's a perfect job if it wasn't for owners, employees, and clients. So it kind of tells you a little bit how you need to balance this out. And obviously, one of the things when the idea was born in the management team, we actually had the execution power within the company. So we then started the process. We tested out. We did a little bit secret in the back room with some techie guys, a few tests, and then we went to the employees and showed it to them. What if the computer can do this for you? Wouldn't that be great? And they say, yeah. But again, well, what about my job? So again, it's kind of an ongoing process where we need to actually work actively with them. The other part is obviously that the investment we're doing here doesn't come for free. No. So obviously I also have to deal with the board and the owner to kind of explain to them what the value is for them. And obviously the value here is automated processes, scalability, and value of the company. So in a way we have to kind of work it both ways. But I think the process is there now, and obviously with this first version where we have the early wins, or low-hanging fruits as we say internally, this is actually immediate benefits for employees. So they see, wow, this is actually helping me in my job. So I think this, again, getting back to the evolution, not the revolution thing, it's about showing them it gives you benefit. It gives you benefit. Wow, I can do the job much quicker now. I don't have to dig into all these different data sources because the information comes to me.
Thank you very much, Doug.
Right.
The next presenter is actually me and my co-worker Stein Irgens, also Knoll and Tott. We are going to present the Norwegian Cognitive Center and what we do in our daily work. But also we're going to present some new feature launching today. So I just start with some slides, because we all need to prepare for change. We know that 95% of all interaction with clients is going to be AI-based in just 4 years, nearly 4 years. We know that a third of the most important skills we need in 2025 is absent today. And as I said initially, AI is the single most value creation for a large number of industries, as we have shown here today. Therefore, the NCA Media took initiative to start Norwegian Cognitive Center together with 5 other industry clusters, 4 industry clusters in Norway, totally 5. And we went to IBM for partnership, and there is a couple of reasons for that. There's several reasons, but 2 of them is important to mention. That IBM does not look into where you have your data. You can have your data at Amazon, Google, under your desk, or whatever. And the second part is when you're choosing a tool for doing a task, you choose the best tools. And both Watson is in the magic quadrant of Gartner, both on data and on AI. So that's the reason why we went this journey together with IBM. We have with us research, academia. We had with us health, the public with Bergen Kommune, and a lot of others. And what we are trying to do is enabling your competitive advantage, like we have tried to do together with ShareCat. And what we offer is 3 different concepts. It's inspire, try to inspire people to learn and use AI. That means creating a bit of panic. The world is going forward, you have to look at this, and some knowledge around it. And there is a lot of company that has data, but don't know what kind of concept could we use our data to. And then we have a garage method that we help them identify the use cases. And we also build a visual prototype. This is how it could be. And they get an offer. This is how much time it will take to develop the MVP and how much it will cost. And then we have other clients like ShareCat who has the data. They know what to do, what kind of use case they want to build, and we help them there. And when it's coming to the scale, we are out, but we want them to get back to the inspired part and do like Doug just did. We do a lot of events through the year, and we have a whole bunch of offering. We are offering you free of charge, IBM Watson in the project phase. We support you with AI experts. We have a learning arena We help you with public funding, because when you're developing AI, this is innovation, and Innovation Norway has funding for this for your organization. We help you with guidelines and governance. We have our AI lab in the 9th floor here, and we have 2 startup programs, one together with IBM and one together with NORA, who is all the universities in Norway. We also try to connect students with project and project with students. And those 2 I already have mentioned. But today we're going to launch what we have chosen to call AI Industry Sandbox. And Stein is going to present that, and that is free of charge and part of our market offer now.
So I am presenting free of charge. What you meant? Okay, this AI ladder, as you see here, it's part of the framework that we use from IBM, and that's IBM's framework to speed up the AI within the companies. I will come back to that a little bit later. I'm going to talk a little bit about architecture in this sandbox. It is a sandbox, and this sandbox can be seen upon us in 3 different ways. A technical sandbox. It can be a sandbox where you can use your use cases to solve the problems that you have, and you can also collaborate with other industries. We have done this earlier, not like this, but I know that there has been some work done within the seafood cluster in something called AquaCloud. And some of the important things here within this architecture is that there is a governance within this architecture that allows us to share data in a secure way. So if you have data within your industry that you want to share with your competitors, you can do so in a secure way. And maybe like in the AquaCloud or fish farming industry, they have this problem about sea lice. So if there is a common kind of use case within, for instance, the media industry, we have the fintech, the ocean industry, it can be built up in the same way. But it's not only the technical thing here. It's also the other thing that we in the Norwegian Cognitive Center can provide if you have a use case and you want to try to do something with your data. We also can deliver expertise. We have data scientists, we have data engineers that can help with the solution, and we also have, as Odd said, we have industry experts, so can help you kind of go and attach that solution into this environment. We are using Watson Studio and Watson technology in this sandbox, and that is because, for some reasons, as Odd mentioned, IBM is agnostic to where you store your data. And Watson technology is a proven AI technology. It's a very strong AI technology that we're using in this sandbox. Also, as I said, we can have the use of the data scientists and the data engineers, and also we are trying to attach as much open data source as possible into this environment. Something we have forgotten to mention here, Odd? Well, to be honest, it's not up and running yet, but in the kind of concept of Future Week, I think this fits well in, so to speak. So, but in a couple of weeks, this will be all up running. And I hope that many of these companies out there who are even members of these different clusters can take contact with the cluster and with the Norwegian Cognitive Center, because this sandbox, it's provide both its storage, its database, its security, its processing, and there is a governance within this concept. And the good thing about this, it's nearly too good to be true. It's for free. It's really for free for the users here. So to come up and bring your use case into this environment, and this environment, it's not a production environment. It's an environment for developing, for testing, and for demo. So it's going to be a strong environment regarding testing, and that this sandbox facilities that we are bringing into this sandbox. And I told you that I will come a little bit back to this. No, not to to that one. Just a ladder, a ladder. But I don't think you need that ladder. You can go out to tower number 3, and you can take the elevator. Instead of using the ladder, you can take the elevator up to the 9th floor, and you can contact me and Odd, because we all need you to bring some use cases into this, because it's nearly too good to be true. You get all this for free, even with data scientists and data engineers. It's a no-brainer. You just have to run up to the 9th floor, even when we were finished here. It's just a queue up before we got filled. Okay.
Also, if you as a company has data, you want other to challenge your organization, come to us with your data and invite people to use your data to build new services, new models, etc.
Good.
Thank you very much for attending today. The presenters, if I get Ketil, Dag, and Ingrid up on the stage, I have something for you. And I also want to remind you that Morten Goodwin, Mr. AI in Norway, is coming today. Thank you very much. Thank you very much. And this is beer made a recipe with AI. Thank you. Thank you very much.